Okay, welcome to day 6 of our Intro to Android course. Today we're going to talk about collections, and that's arrays, lists, all those things. In fact, we already touched on those a little bit yesterday, and we'll dig more deeply into those and talk about how they're going. I hope your projects went well yesterday with the palindrome app assignment. It's going to be really helpful for you just to follow along and perform those projects as we go through the course. You'll be able to better understand what we're doing as we continue forward, especially as the topics get a little bit more complex and they start building upon each other. So for this week, or today, our objectives are that at the end of the night, you'll be able to understand what an array is and be able to create one as a data member. You'll be able to access and manipulate data in an array. You'll be able to iterate through an array with a loop. You'll be able to create a list and manipulate data inside of it. And you'll be able to understand the difference between arrays and lists. And we'll go over each of those in depth today. Our assignment today is going to be a thesaurus app. So what you'll do is you'll have the user type in a string, type in a word, and then you will search through an array database, find that word, and share all the synonyms associated with it. And we'll get into that as we go through. So first, what is an array? And how do we create one? So arrays are a data structure provided by all programming languages. They're a fixed size defined in creation. They are a list of objects or a list of variables, and you declare, when you create them, you declare what type of variable they are and how many there are going to be. Like I said, arrays are a fixed size, so once it's full, you can't do anything about it. What you would have to do is you have to delete it and create a new one, or you create a new one and then copy stuff from the old one to the new one and then delete the old one. Most arrays most developers picture arrays as tables. You can see over here an example of that. Your array here is what's called a two-dimensional array. So you have a column and you have a row, and these are two different dimensions that you have. And this is kind of how you can picture that. A standard array is just going to be a single dimension, and then a two-dimensional array will be an array of array elements. And then if you go to like a three-dimensional array, you have an array, which is right here. So these are 3 elements of this array, and each of its elements is a two-dimensional array. And they keep wrapping around each other until you get more and more complex. An array is going to have any number of dimensions. One of those things that was kind of hard to picture. It's easy to picture a list, a single column. It's fine to picture a table. A cube is stretching it, but once you get beyond that, it's kind of hard to picture that as physical dimensions and picture arrays that way. So one example that I like is an address. So you have your street number, your street, your city, your state, and your country. So in this example, your first dimension of your multidimensional array will be an array of countries. Then each country will have its own array of states or departments. Each state will have its own array of cities. Each city will have its own array of streets. Each street will have its own array of street numbers. And then you use all 5 of those dimensions to get your full address. And that kind of shows you the power of arrays as well, is you can whittle down data and organize it in such a way that's easy to access, or relatively easy to access. You can also associate related data. So in this example, all the cities that belong to each state are all associated together. The vast majority of the time, you'll only use 1 or 2-dimensional arrays. There's only been one situation in all my experience that I've had to use a 3-dimensional array. And that was kind of stretching understanding and just be able to wrap your head around it as you're working through it. It gets more and more complicated. As data gets more complex, there are better tools. We'll get into objects on Thursday. Databases we do that a few weeks into the full course, and all these things are used to be able to associate and build data. So let's jump into Replit. So create a new REPL. I'll give you a second for that. We're going to start creating our arrays. So here we go. We're going to go ahead and create an array of integer values, of int values. So you have an int, and then you use these braces, and then you give it a name. Integers equals new int, and then you have braces again, but this time you're going to put the size of the array inside of the braces. So if I want an array of 10 elements, then you have that right there. So this is going to create a new array of int values called integers, and that's going to be a size of 10. So right now it's creating an empty array that holds 10 values. Another way you can create an array is the same thing, int brackets, and then int 2, int init. How do we do that? So this is called initializing it with values. So you go new, or you don't even have to use your new. What you use curly braces, and then you fill that up. You go 5, 4, 3, 2, 1. So just like parameters in a method, you separate them out by commas. So what this does, this creates an array that's 1, 2, 3, 4, 5. So I have size 5, and it fills those slots here in order. So index 0 is going to have 5. Index 4 is going to, or index 1 is going to have 4, 3, 2, 1, just like that. So that's how you can create an array. So now let's figure out how we can access the data inside of that array. So accessing and manipulating data in an array. We do that right here. So arrays are accessed by their index, just like we dealt with strings yesterday. This index gets translated into a memory offset. So in order to process elements in an array, we use an index operator. We use the index operator brackets right here. So the way we declare it, we just access those like this, and you give it an index, and that's how you access it. So let's go back to Replit and see an example of that. So you can see here, if I go int init, and then I'm going to access the, let's go the second element in that array, and I want to print that. So I'm going to wrap that in a system.out.println, and then if I run that, it's going to declare this integers one. We don't care about that one. It'll declare this one and fill it. And then you're typing out system.out.println, and it's printing the element at index 2. So you can see right there. What if we want to access and assign a value? Do it the same way. And then you're just going to assign the value of 4. So I'll walk you through kind of how this is done. What's happening here. Our integers is an array. What we're doing here is we're unwrapping that array like an ogre or an onion or a cake or a Christmas present. What you're doing is this word in code references an array. As soon as I use the index operator, it's taking that array, it's unwrapping it, and it's going to give me an int. So it's treated, you treat this just as you would treat any int value. But what about multi-dimensional arrays? Let's try a string array, and this is going to be a 2-dimensional array, and you do it the same way, but you're adding 2 sets of braces instead of 1. And this is going to be strings. I'm not creative when it comes to names, especially if they're just straight up examples. And then this way, what we do here is we'll do new string, and you use your double braces. But this time we have to provide sizes for 2 in 2 dimensions. So the first one we can do 4, and the next one we can do 15. So what this is doing, this is creating 4. Okay, let's start at the beginning. So this is going to create 4 different arrays that are each 15 elements long, and those elements are going to be strings. And then the way you access that is you take your strings and you're going to access it with your two arrays. So we unwrap it with this one. So at this point, at this point we have a two-dimensional array. As soon as I unwrap it with these, we're going to get to, now we have a one-dimensional array. And then finally we're going to unwrap the last layer. And that gives us a single element in the array, which is a string. And then we can assign it the value of, this is my string. And now what we can do is we can put that in our print statement. And we can see what happens. So what this is doing is we're declaring this string, declaring strings to be a two-dimensional string array of these sizes. Then we're accessing this array, the array at this index, and then the element at this index of this array. And we're assigning it a value, and then we're taking that same point and we're printing that out. So arrays are very powerful, especially when you're dealing with associated data. So here we declared, that's 10 variables that we've declared. But it doesn't make sense to have it be multiple values. So if I have an X, Y, Z, declaring those as an array doesn't make sense unless they're associated with each other. Just like the elements in a street address are associated, these have to be associated as well. So let's look at that and see what happens there. Looks like we have a question in the Q&A that we never use. Size is required in this situation, and you can't change it. What you have to do is you have to delete this array and create a new one. At the end of today, we'll look at lists, and those things can be changed. Feel free to add any questions to that as well. I appreciated that. So let's move on to the next part where we get a little bit more power in our arrays. So now what we can do is we can use a for loop, or any loop really, but the most common are for and for each loops to iterate through an array. So there are multiple ways to work through an array, and these are the most common. We've already talked about for loops, and you can set the number of the loops to be equal to the length of the array, and we can see that here. So we have table cells.length. So this is going to tell us how long the array is, and as long as we're less than that, we can go through it. And this is doing a two-dimensional array because it's a two-dimensional table, and we can do that there and iterate through that and access the different elements. For each loops are pretty cool. High-level languages like Java give you this tool, and it automatically iterates through an array and just gives you access to each element as it gets to it. These are great for simplicity, but they don't work if you need access to the index of the item that you're looking at, or if you need to make changes to the array. And then for multiple dimensional arrays, you use nested loops. And what that means is you're having a loop. Whoops. Can't highlight that text. You're having a loop that's inside of another loop. And so these new loops, this loop is nested inside of this loop. So let's start manipulating our data. So if I go into here, let's take first we'll just do our int init, and we'll do a for loop through that. For int I, and remember to follow along with me, plus I. Whoops, I skipped one part. We need to do I is less than int init dot length, and then we add our curly braces, and then inside of it we're going to go system dot out dot print line, and we're going to print int init, and then for our index value we're just going to pass it I. So what this is doing is it's giving, and then we need to also assign I to be equal to 0. So I is starting at 0, so it's going to be the first element in the array. And it's going to start at 0, and it'll print it out, and then when it finishes the loop, it'll increment I. And then it'll print the next one, and it'll increment I until it gets to be the length of the array, and then it stops once I is equal to the length of the array, because remember, since they're indexed at 0, the length of the array isn't a valid index. You have to do length minus 1 to access the last element. So let's try that. So here we go. We've built them up. Now we're running it, and what we should see is it should print out each one on a separate line. But what if we want to do something else? What if we want to do a two-dimensional array? One thing we can do with that is we can use a for each loop. So let's try that. So if we go for paren, and this time we're going to declare an element. So what's going to happen here is we're taking our array of strings. Each time it gets to an array, it gets to an element, or each time our loop gets to an element there, it'll store it right here in our element variable, and then we can access that in our code. So then we can go system.out.println element. But we're forgetting something here. Our strings array is a two-dimensional array. So what's happening here is we're only accessing one element in the array. And it's not going to return that because we're unwrapping it layer by layer. So if I unwrap a two-dimensional array one time, what am I going to have? And I'll actually let you guys answer this one. So what's happening is each loop is going to unwrap the element once. So if we have two arrays and an element, we unwrap it once and we're going to get down to just the single dimensional array, and then we need to unwrap it again to get to our string. So what we're going to have here, we're not going to have an element, we're going to have an array. And then we get our for loop again. And this time we're going to have a string because we're unwrapping it again. And now we're going to have our element. And then this is going to be array. So what we're saying here is we're saying we have a two-dimensional array here. We're going to unwrap it once with our for each loop, and we're going to get a one-dimensional array. And what we'll need to do here is we'll need to delete this and move it back there. And then once we have our one-dimensional array, we're going to unwrap it again and get our string, and then we can print our string. So I run that. What's going to happen? It's going to go through 60 times because each element has 4, and then it has, we have 4 arrays, and each of those arrays has 15 strings. You can see here we had 60 of these. And you can also see that we don't have access to any of these. We can print them, but we can't change them in this way. In order to change them, we would have to use a for loop with an index. So we can use the index like we do up here to assign it a value. So let's move on to the next part. Is we're going to talk about lists. Lists are an awesome tool when you don't know what when you don't know the size of your array or if it needs to scale. So a list is a dynamic array. It is an object, so it can handle a lot of things behind the scenes, just like the string does. And it'll dynamically resize your array. There are a multitude of different types of collections, and they all stem from the list. And a few of the common ones are array lists, vectors, and stacks. On the outside, they appear very similar, but on the inside, they do things differently. So one difference between an array list and a vector, these are the two we're focusing on right now, is the way they expand. So I have a question for you guys. We know that arrays are a fixed size. So how do these make them dynamically sized? What do you guys think? You can go ahead and answer in the Zoom chat. I know it's so rare that I actually provoke responses. Well, you guys are party poopers. So what they do is what I had mentioned before, is in order to create an appearance of a dynamic array, what you have to do is you have to destroy the original array and then create a new array that's bigger. So when the array fills up, the array in the backside of our lists, it'll create a new bigger one, copy the data from the old one, and copy it to the new one. And then both the array list and vector handle those differently. What a vector does is each time it fills it up, the vector will create the new array that's twice the size of the original array. An array list will increase the size of the array by 50% each time. So what happens is vectors will use more memory, but they don't have to increase the size of the array as often, which is a resource-intensive process. So there are give and takes, and you have to know how your data is going to be used, how your lists are going to be used before you decide how to use it. The most common is array lists. Most of the time, at least when I use them, array lists just don't need to grow a ton or very often. So you can go ahead and use that and it'll just slowly increase it. Another thing you could do is when you instantiate the lists, you can give it a basic size. So if I know that my array is going to have at least 100 elements, I'll just give it 100 and it'll start off with 100 elements. Another type of list is a stack. This is what's called LIFO, L-I-F-O, or last in, first out. So it's like a stack of bacon. The piece of bacon that was most recently added to the stack is also the next one to be removed and eaten. Stacks are used in Java to manage memory allocated to each method. So you'll hear that when people talk about the stack. It's because Java, when you call a new method, it'll store memory on top of the stack and then it'll pull it off in that order. So you get the last in, first out order. So let's dive into array lists, since it's going to be the most common one you'll use. We're going to create a list and then we're going to manipulate data inside of it. And then we're going to get to the end. It's going to be pretty short, but then I have a fun little demo that we'll deal with at the end. So when you declare an array list, just like when you declare an array, you have to tell it what kind of data you're going to have inside of it. So in this situation, we have an array list that has a list of integer objects. And then we're doing a new array list, and then you add stuff to it with the add. If you use the add, it adds data to the end of the list. Get will retrieve the data from that specific index in the list. So let's dive back into Replit and see that in action. In order to use an array list, you need to import the java.util.arraylist. There we go. And that's importing the library just like we had to import our text view or our buttons. We can go ahead and delete this. We can also delete this, just so we can step through that and then make it a little bit easier. So we're going to do array list. We're going to tell it we want to store, let's do ints. List, and that's going to be equals new array list. And you can see here, this drop down is showing us we can give it a collection, so we can give it another type of collection, and it will build the array with that starting with those initial values, or we can also give it an initial capacity, and then finally we can also give it just nothing. Let's just do nothing for now, and this is just going to create a basic list. So let's see what happens. It might not work. might not like it as much. Let's see. List.add 0. And then we're going to go here. We're going to change this to a list. And we're going to change that to an int. And we'll run. I am wondering. So we do need to use. You don't deal with lists of primitive data types very often. And apparently you can't at all. So you have to use the full integer value object. Integer object rather than integer data type. So there you go. This is giving us a 0. This is just a replit not liking something. So one thing you can show the advantage of a list is I can go here. If I go for int I equals 0, I is less than 52. That's a really random number. Plus plus I. And I wrap that. And then in our list, we're going to add the value of I. And then we're going to print everything out. We run that. And there you can see it added all these elements, then it printed them all out. Finally, what we can do is we can use our system.out.format, what we did yesterday. Then I can say yeah, you have to use integer dot to hex string. We haven't done much with hex. And then we're going to give it, it's going to be a string now, so we're going to do percent string. And we're going to pad that to be 3 characters. And we're going to change this to be 255. And we're going to see it count. Let's see, what did it not like? Variable I, int element. Oh, it's because we're saying it's an int, but it's actually an integer. And we don't have an I. We're using our element, not an I. Let's try that again. So you can see here it printed out all the values, and since it's a format, when we didn't add a -n, it's printing them out kind of a little all on the same line. You can see it's counting up in values, and that's everything that we have in this element. So now let's jump into Android Studio. Let's create a new project. And this is going to be a collections demo. I'm going to put it in my temp directory. Oh, documents. Temp. And then we're going to go collections. So remember, create a project along with me if you can. Oh, that's why. We have to create a new directory. There. Now it should be happy. Next. Fine with that. We'll create an empty activity. Yeah, we'll build something a little bit with this. This is just an example app that we'll be working on during the main course. This is what I was putting there. So as it's building, we're going to do something a little different with lists. First thing, it's all red because it's building. Change this to linear layout so you don't have to deal with constraints right now. We're going to add a scroll view. And we're going to do more with these on tomorrow, I believe. More with scroll views and other types of views. I wanted to show you. This is going to match parent. So we're creating a scroll view that will fill the window. And scroll views can only have one child, so we're going to add a linear layout down here as well. So we can, in fact, just delete this. And again, we'll go more into all of these elements tomorrow when we talk about layouts. We're going to give this an ID. List layout. So here's our code. We have a linear layout that we're going to add our orientation to make it vertical. We're going to add another linear layout. We're going to make it orientation vertical. And then the second linear layout is nested inside of a scroll view. So what a scroll view is it makes a view that can scroll the elements inside of it. So we'll see that, and we'll see an advantage of what we can do with lists doing that. So we're going to grab a handle to our linear layout. This is going to be our layout list. Make sure we named that right. Almost layout list. Remember, we do the element first. And then here what we're going to do is we're going to come down here and we're going to create inside of here, we're going to create our array list. And that's going to be an array list of, let's do integers again. I like seeing numbers in binary and in hex. I think that's kind of fun. Integers, and that's going to be a new array list. I'll remember it has to be, see, the Android Studio knows what's up. There we go. And then we're going to populate our list. Oh, first we need to create our for loop. It's less than. Let's go 1024. Let's give it a big one. And then we go plus plus I. So what we're going to do here, while I kind of tell you what the end goal of this is we're going to create a list of just the values, the integer values, and we can just scroll through them and see them. But first we're going to populate our values. So integers. And in fact, you don't even need a lot of these things. Dot add I. So there we go. Another good thing to do is if we extract this as and you can just right click, refactor, extract as a constant. We don't want to move it to another class. We want it to be right here. And that's going to be the number of elements. So now we can easily change that up here, and it's at the top so we can see that. So we're going to add that. Another thing we're going to need to do is in order to add these to our scroll view, we need to create elements in them, create views. So what we'll do here is we're going to dig into, actually first we're getting this failed the instantiate error. So remember what we need to do is you need to go to your resources, values, styles. I fix that bug soon. And we just do base. Another thing you can do too is you can play around with the themes. And these are just the base themes that Android can give you. If I just do theme act, if I delete that, it'll go from doing a light theme with a dark bar, and you can see here it's going to be a dark theme, which as you can tell with everything, I like the dark themes because if you go with the light theme, it blows out my eyes. Let's zoom in again. I apologize. I'm trying to get better at zooming in so everyone can see it clearly. So let's play with, so the next thing we're going to have to do is we created our list of elements right here. These are the list of elements that we're going to want to print out, but we need to give it a structure to print. And there are multiple ways to do that. We'll get into more and more as we go through the course. One way that's kind of fun, or it's kind of, I don't know, my view of fun is kind of weird. I understand that. So we give it a text view. We're going to match the parent's width, and we're going to wrap the contents on its height. So the text view is going to be as wide as the screen. And the reason why I do that is I can add the alignment, the text alignment property, and center that. So now our text will be centered in the screen, which is nice. And then you can change the alignment however you want. Next thing we're doing is we're going to put some placeholder text. And we just do placeholder. So this is going to show us what our element's going to look like. And in fact, we're going to delete this element and recreate it programmatically. I want to make the text bigger. So if I do size, and follow along with me as long as if you are able to, let's do 24. Use SP, which is how Android handles font size. That seems like a decent size, but let's make it a little bit bigger. Let's go 32. I like that. And then finally, I'm going to add some padding. There are two ways to add space between elements. If I use padding and I go 10 dp, what happens is it takes this border and it puts padding inside of it. Let's give another element. I'll just duplicate this element to show you. So padding adds spaces inside of it. If I change this to be from padding to be margin, this adds space outside of it. So I'll just delete this so you can see it. So if I go here, you can see the blue is wrapped very tightly around our placeholder there. In fact, let's just go 20. Let's give it bigger. No, you. Layout margin. There it goes. So you can see our blue is tightly wrapped around here. This is our element. Margin places space around it. Whereas if I change it to be padding, it'll do, there's our blue element here, and it brings the space inside of it. And if I click and drag that, it'll increase the height. That's kind of cool. That's a new feature. So it doesn't matter as much here because we only have it inside of this single space. But if you were to play around with that and use different types of elements, that'll make a difference. So we'll spacing about 15. So now what we're going to do, I'm deleting this element, and I'm going to cut this. I'm going to come back into here. I'm going to create a new method. We're going to make that private to our class here. It's going to return us a text view. So this is going to be, we're going to call it default text view generator. And then inside of it, I'm going to create a block of comments, and I'm going to paste my XML code. This I can now use as a reference because I generated the element here, and I saw how I liked it, and now I know, okay, these are the settings that I have to make to change that. One thing we're going to have to do as well is we want to pass it in the string that's going to be our display text. So what this method is going to do, what we're going to do here is we're going to have it generate a text view that has the default configuration and our display text. And we're going to call that from here and bind that to our linear layout. So walk through how to do that, and then I'll let you go. This was a shorter day, but I wanted to give some time to work with this. This is kind of a fun demo. So what we're going to do is we need to create a text view. And that's going to be our view, and it's going to be a new text view. So you notice how I'm not getting it, I'm not doing find view by ID, I'm getting a new text view. What is it missing there? Control B. So what it needs our context, the context of our app. So what we can do is we can pass it this. Yep, there we go. In fact, what we want to do is we can go context. So this is going to create I want this to be private. And then here we're going to say context equals this. Context is something that Android uses to determine where to display something. It's like in this situation, our context is our main activity. If we had a separate activity, then it wouldn't know where to display it until we gave it a context. So that's where we're using the this keyword, because it's this activity is the context what we're using. And then I can change this to be context. And the reason why I'm doing that is if you're in a listener and use this, it's going to give you a different, it's not going to give you a context, it's going to give you something else. So now let's go through each of these. Our placeholder text is going to be our display text. So we can go view.setText is display text. Then we will go view dot, our next thing is going to be set size, text, or you can just type size and it'll give us a set text size. And then we can give that, so we can either give it a unit or a float size. Let's try something. Let's actually go to our documentation. So bring up Replit. Let's go Android text size. So let's try and see if we can get to the documentation. So there's our text view. So what I'm looking for here is a constant value. So just like we had our constant up here, whereas I can reference this by name, a lot of Android values will have constants as well. So let's see if I do SP, search there. What was it asking us? Let's jump back and see. It's asking us for, in fact, we can just jump into here. Let's see, set text size. So there we go. It needs our unit and we need the size value. So let's see. And default net value, set the default text size for a given unit and value. See typed value for possible dimension units. So let's see that. Right click, open a new tab. So here are a lot of different constants that we can use. So what we're looking for is complex unit SP. So, and that tells us that it is a scaled pixel. And remember that matches what we have here, SP, which is a scaled pixel. So if I give it a, what's that value? So complex unit SP inside of typed value. So I can go here, if I go typed value dot complex unit SP, there it goes. It knows what I wanted. And then I can give it a 32. And that, so this line of code does the same thing that this line does, except this line is done when the view is created, if it's in the XML, and then this line is done whenever we call it. So you can use this to dynamically change the size of the text. Then we go, we want to set our padding. So view.set padding, and we'll give it a, and same thing. Okay, so this, what this wants is they want padding for each different size. So if I go 15, comma space 15, 15, so 15, so I'm giving it parameters for each different left, top, right, bottom, 15 dp for all of those. And then view.set text alignment. And then what does it want here? It wants an int text alignment. So let's go back into our documentation. And we're going to get rid of this. And then we're going to find text alignment. So view.set text alignment. We'll click that. And we'll go to, see, text alignment. We want the method to do that programmatically. So if I go set text alignment right here, I can click here. I really like Control F to search or Command F. It's really nice. So here we go. Here are all the different values that we need. And I want alignment, text alignment center. So if I click that, text alignment center is part of view. So what I should be able to do is if I come back into our code, I go view dot, there's our text alignment center. This is why IntelliSense is so awesome. Because I'm doing set text alignment, it uses this context to say, hey, you're looking for a constant. Here are the constants that are related to text alignment. It's really, really great, and I wouldn't be surprised if they had a lot of machine learning. Being Google had a lot of machine learning built into that on a global scale. And then we need to set our width. View.set width. View dot. Let's see if it's giving us any of these. That's autofill. Scroll, system UI, text correction. So that's, as soon as I started praising it, it just didn't like it anymore. So let's go back here. And we're going to go set width. Nope, doesn't like that. Width. So I'm doing a search over here on this side. Set minimum width, layout width. So there's get. There are a lot of those. So get width, let's just see if we can scroll down and find a set width. Set layer, set minimum width, that could be useful. We'll have to keep that in mind. Set scale. So let's go back up to set minimum width and see if that's helpful for us. The minimum width the view will try to be, and so that's the width in pixels. For example, if the parent layout constrains it with less available width. So that's an interesting parameter. Let's see what happens if we set it. It's interesting. Let's see if we can do a quick search to see, because it's giving us that. Android view set width. And you can see there's a lot of different options there. In fact, this is exactly what we want to do. So let's look into that and see some of these resources. So this is really, I mean, a lot of the stuff that you'll be doing too is kind of digging into here, trying to make your Google foo. So let's see. That's setting it to the third of the screen. So that's not necessarily what we wanted. So here we go. Bam. Linear layout params match parent. So we should be able to try that with our text view. Hope it doesn't like that. What was it saying? Layout params? I don't think it's going to like that either. So let's just set our width to be 2000 pixels. And we'll set our height. We don't need to set our height because it'll default to wrapping around the parent. Let's see how that goes. So we've built all of that. And now we're just going to return our view. And now let's go ahead. Now that we can't build it yet. So here's our code that's generating our view. So now let's go ahead and add it. Let's generate views. But what we want to do is we want to do a for each. We're going to loop through our integers. And we're going to default text view generator. And we're going to give it our, we'll do binary this time. So integer dot to binary string num. So there we go. We got our default text view, but we're not doing anything with it. What we need to do is we need to come back up here. We get our layout list. We need to attach that handle. Find view by ID, r.id.list, layout list. And now we're going to come here, and for each of these elements, we're going to go layout list dot add view, and we're going to give it this view. So let's walk through how all this, well, let's start generating it because that'll take a while, and let's walk through how this is done. So here we're creating our array list. We're filling it with integer values from 0 to number of elements, which is 1024. From there, we are doing a for each loop, and we're stepping through each of the elements in this list. We're going to add, for each of those elements, we're going to generate a view that's a binary string, and we're going to add that view to our layout list. So we were having it build in the background. Let's see how that goes. Let me scale it down so you can see it a little bit better. So make sure, okay, so I didn't like that build. Let's click that again. Sometimes I wonder if they have some kind of analog I need to press for a certain amount of time, because it just doesn't like my clicks sometimes. So you can see a lot of these demos that we've done or projects that we've done in this symbol. So these are all the different apps that I've run. So if you wanted to rerun any of the apps, you can just do like you would do on a normal phone. So it's building. We can also, now that we're done with this, we can go ahead and clear out our text. Our reference text, because we don't need that anymore. It's running. Another thing too is in this example, an array list is unnecessary. That is because we have a static number of elements. So what we could have done is just create an array. So if I do int array, we do int braces array equals new int, and we just pass it in our, oh my goodness, it's been a long day, our number of elements. That'll be effectively the same thing, except for instead of add, you can come out this line as well, and you just do array with the index of I, and we're going to assign that a value of I. And then here we're going to go array and change that to an int. The same thing. So it looks like it didn't like our build, so let's see what's happening there. Task, let's trash it and try it again. Let's click the debug so we can see what's going on here. So let's say, okay, I have our log view up so I can see what's going on. I'm going to click the trash to clean it up. It's installing, it's launching, it's attaching. Okay, so there's something that it didn't like. Find view by ID. So if I click here, so I can see here, anything that's gray is not your code. This is Android resource code. They're Java libraries. So if you go to a blue link, it'll go reference your code. So r.id. Oh, I made a mistake. I made this mistake earlier too when I was building something else. Instead of dot, we need equals. And what's interesting is that it's not complaining to us here because all layout or all component objects have a find view by ID. So it's trying. It was really trying to do it, but it couldn't because it didn't have anything that had that ID. So there we go. So here's our elements, and now we can scroll. So there's our scroll view, and we can just scroll through and see all the numbers counting up in binary, which is really, really boring. But you can see here that we have this list, and it was able to populate all of these things with just a number. I mean, really, our main method is only 24 to 38 lines of code, and that's giving it generous spacing. The only stuff that's doing anything is right here. And it can get all those and store them all too, so we can get those and reference them however we want. And that shows you kind of the power of lists and what you can do there. You can step through, you can store a lot of things and do all those things there. So I just wanted to give you kind of that example and show some of those things there. Let's jump into our assignment for the day, and then you get to go. So I went from being really short to being just on time. Some of you were appreciative and some of you were, don't worry, I was a student once. So what we're doing here is we're going to practice the skills learned in collections.java. You have your synonym, which is a word with the same meaning as another word. Right here you have your example stuff right here. So this is the code that you have. You'll just copy and paste this into your onCreate method in your app, and then you can reference that. You can add to it if you would like. And what you're going to have to do is the user is going to input some text. you're going to search that array for that text. So using a for loop, and you're going to look for the first element in each array for that text. Be sure when you're comparing, use the dot equals, and then you make sure to change both of them to be to lowercase so that you compare two lowercase elements or two lowercase strings. Then finally, you're going to show the synonyms. So once the user is going to type it in, push a button, if you find it, you're going to show everything in that array in another view. And so there you go. That's what it's going to do. Thank you guys again for participating today. I appreciate you attending the class and doing all the work, and I think that's really great to be able to do that. If you have any questions, feel free to message the PMs or me, and we'll get to it as soon as we can. Thanks again for your time. Thanks for working with us and participating in Lambda School. Have a good night and good luck.